Hello everyone, I am Karthik, Assistant Professor of Mathematics, SNS College of Engineering. In this lecture video, I will explain about triple integration. Definition and concept of triple integration. Triple integration is a mathematical operations that this extends the concept of integration from 1 and 2 dimensions to 3 dimensions. In the essence, it involves the finding the accumulated effect of a function over a three-dimensional region in a space. The basic idea is similar to single and double integration. Understanding the triple integral notation. First, function. The function being integrated denoted as f of x, y, z. It represents the quantity you are integrating over three-dimensional region. Next one, region. The region of integration is denoted as R. It specifies the three-dimensional domain over which the integration is performed. It defines the bounds for each variable x, y, z. Third one, volume element. The differential volume element denoted as dV. It represents an infinitesimal volume within the region of integration. It is typically expressed as dx, dy, dz in Cartesian coordinates. Limits of integration. The limits of integration determine the boundaries of region R in each direction of x, y, z. The triple integral notation combines these components to express the accumulation of the function f of x, y, z over the region R. It is represented as triple integral R f of x, y, z into dv. Changing the order of integration. Changing the order of integration in a triple integral involves rearranging the order in which the variable are integrated over. This can be useful for simplifying the integration process or for adapting the integral to different coordinate systems. The order of integration can be changed by carefully choosing the limits of integration to ensure that the volume is still covered completely. For example, consider the triple integral or f of x, y, z into dx, dy, dz. Then the general process for changing the order of integration is determine the limits of integration for each variable in the new order. Next, rewrite the integral with the new order of integration and corresponding limits. Third one, evaluate the integral using the new order and limits. Triple integrals in cylindrical coordinates. In cylindrical coordinates, a point x, y, z in three-dimensional space is represented using the cylindrical coordinates r, theta, z. R is the distance from the z axis to the point in xy plane. Theta is the angle measured counterclockwise from the positive x axis to the segment connecting the origin. Z is same as in Cartesian coordinates representing the vertical position. The conversion from Cartesian coordinates to cylindrical coordinates is given by x equal to r cos theta, y equal to r sin theta, z equal to z. For example, triple integral f of r, theta, z into r dr d theta dz. Triple integrals in spherical coordinates. In spherical coordinates, a point x, y, z in three-dimensional space is represented using the spherical coordinates rho, theta, pi, where rho is the distance from the origin to the point. Theta is the angle measured counterclockwise from the positive x-axis to the projection of the point onto xy plane, that is azimuth angle. Third one, pi. Pi is the angle measured from the positive z-axis to the point. The conversion from Cartesian coordinates to spherical coordinates is given by x equal to rho sin pi cos theta, y equal to rho sin pi sin theta, z equal to rho cos theta. In spherical coordinates, the volume element dv is expressed as rho square sin pi d rho d theta and d pi. Triple integration and mathematical concept, limitations and challenges of integration. First one, complexity. Triple integration can become extremely complex, especially when dealing with irregularly shaped regions or functions. Second one, computational resources. Computing triple integrals, particularly for complicated functions or regions, can be computationally intensive. Third one, choice of coordinates. Selecting the appropriate coordinate system for triple integration is crucial. Determining the limits of integration. Finding the correct limit of integration for a given region in three-dimensional space can be challenging. Physical interpretation. Interpreting the results of triple integrals in real-world applications can be challenging. Numerical approximation. In many cases, triple integrals cannot be solved analytically and must be approximated numerically. However, numerical methods may introduce errors. The accuracy of approximation depends on factors. Thank you.